everybody, and welcome to this webinar on InfoWorks ICMLive, the flood forecasting and operational modeling solution from Innovyze. First of all, a quick word about Innovyze ourselves. We are a global company with around 200 employees worldwide, and importantly, some 65% of our staff are involved in the direct support and development and research that drives our product portfolio. In terms of our areas of operation, we operate in the United States, across Europe, in Asia, particularly in China, and Australasia as well. Innovyze have a broad solution of products, but they can be categorized into water distribution modeling, asset management, operational analytics, storm, sewer, and flood modeling, which is what we're going to be talking about today, and drainage design. So the challenge when it comes to producing an operational modeling or flood forecasting system is to allow a utility company or a city to have some advanced notice about the potential risk that they are subject to from flooding. And that could be providing flood risk alerts or just alerts about the general risk to the system and the assets that are dealing with stormwater management. And it's important to provide this information because knowledge means time, and time is really the most important thing that a utility or a city has to have in order to take action to mitigate against unwelcome behavior. Now, what do we mean by unwelcome behavior? Well, essentially it's flooding, which could be from any number of sources. It could be CSO spills or SSO spills if you're in the United States, or it could be blockages that are building up within the system. And of course, blockages will ultimately result in flooding or spills from SSOs and CSOs. So how does an operational system work? Well, essentially the utility company or the city will use the investments that they already have in order to gain a deeper insight into the current and potential future operation of their network. And they do this by utilizing a hydraulic model, which today we tend to refer to as a digital twin, but also rainfall observations and rainfall forecast data. And this is information that utility companies particularly will almost certainly already have. The ICMLive system from Innovyze, it builds upon the renowned and well-established InfoWorks ICM hydraulic modeling package, which has been specifically developed for urban flood modeling situations. InfoWorks ICM provides a unique, single, fully integrated 1D, 2D simulation engine, which allows it to model networks containing sewers, watercourses, overflows, or any combination of those three items. We also use a very efficient irregular triangulated mesh to look at the surface of the model, and this allows us to process ground flows, flood flows, very, very efficiently and very, very quickly as well. And speed is of the essence. As I said just earlier, time is what the utility company needs to get back in order to be able to develop a response to a potential flood situation. So when we're developing operational models, we need to target run times of around 25 minutes or less, and that should be the case even for quite complicated models. So once we have developed our hydraulic model, we have our forecast information for future rainfall events, and we have all the information about previous events, we are in the position where we can produce our operational system and our flood forecasting systems. And this will allow the utility to have foresight into what would previously have been unforeseen events. And this allows them to then develop early warning and action plans to that early warning. And in an emergency situation, any actions which are done proactively in response to a forecasted event will be much better actions and liable to be much more coordinated. Any emergency response that is reactive tends to be rather chaotic in nature and therefore much less efficient than would otherwise be the case. And even when the system is operating in normal bounds, just having a future foresight onto the future flows and depths in your drainage system means you can plan your activity in terms of standard day-to-day maintenance much, much more easily and much, much more efficiently. So how is the ICMLive system configured? Well, we start with those inputs that I was talking about before. So our rainfall information, so that's the rainfall that could be picked up from rain gauges, but today that could also be rainfall coming in from weather radar systems. That will be combined with our hydraulic model, or perhaps models if we're looking at a very large catchment. And in addition to that, the utility company is almost certainly deploying SCADA information to pick up flows in the system, perhaps data on pump operations or water levels in nearby rivers and watercourses, or perhaps tidal levels as well. So all of this information the utility company is already gathering and will probably be coming into some form of data lake. What we do is to extract the data from that data lake to form our dynamic modeling situation. And this is where our models are running all day and every day. So that's 7 days a week, 365 days a year. Constantly looking forward from the current moment in time, some 3, 4, perhaps even 6, 7, 8 hours ahead, in order to give us insight and foresight to the future performance of the system. And this is what we'd call InfoWorks ICM Live. So the live software sits in the middle of a much bigger system. And on this graphic here, we can see the typical inputs, the time varying inputs that will come into our live modeling system. So we've discussed weather radar, but we could also have flow, depth, pump status information. All of that is fed into a central database of time series information. And that is where our InfoWorks ICM Live system then picks up all the data that it needs to run together with the actual network model itself. Based on the forecasts that that network model produces, alerts will then be sent to typically a control room or operations center, or perhaps just individuals via their smartphones. But either way, a decision will be made about an action that needs to be taken to a future forecasted event. That information would go out to the command center, and ultimately that would mean that staff and emergency response personnel would be deployed on the ground. Now, in terms of the challenges that we need to address, we've discussed the time varying data that's classically picked up by our SCADA monitors that are out in the ground, and they will provide an important historian on how the system performed up until now. But we only can go to now situation with our SCADA data. So we can look at the onset of a CSO, we can look at current pumping rates, and we can look at the effect of potential blockages in the system right now. But to look forward in time, we need to change from using just our SCADA sources to using the outputs of our operational system, of our live modeling system. Because once we have this foresight into the future, as a utility company or a city, we are in a much better position to keep our employees safe, and of course a much better position to keep the public safe, which ultimately is the responsibility of all utility companies. And in terms of managing that situation, the structured deployment of response people or resources to prevent flooding is much better done with foresight into the future and with time available. In addition to that, in terms of dealing with an emergency, network operations and optimizations will be much better deployed if we have this foresight into how the system will be operating, both in the near future and perhaps the more distant future. So in terms of changing that graph, the dotted line down the center of the screen on this graph represents the now situation. Everything to the left of the graph is what has happened in the past, what we call the hindcast period, and that's the data that's been collected by our SCADA system. And in the graphic you can see that we have observed flows shown in the green color. At the top of the graph we have the observed rainfall, which in this case could have come from weather radar, or it could have come from rain gauges actually out in the field. Either way, we have a response which is very visible as a result of our SCADA data. What we also have is a red line showing how the hydraulic model, the digital twin, interpreted those inflows, how it interpreted the rainfall, how it interpreted every other influence to give the system response. And what we want to always see is our digital twin being in fact an identical twin. We want to see the outputs of the hydraulic model matching as closely as possible what actually happened in reality. And we can see in this particular diagram that apart from the high peak from the rainfall, where there was a slight deviation between the hydraulic model and the situation recorded by the SCADA data, there's generally a good match between observed flows and simulated flows. And this is important because as we then move to the right of the dotted line into first the nowcast period, the near future, and then the longer term forecast period, if the predicted rainfall, if the forecasted rainfall is similar in nature to the rainfall we have observed in the recent past, then we can have high confidence that our nowcast period particularly is a good indication of software and system performance. And if the software is predicting a peak in flow or a peak in depth that might cause an overflow to trigger or might cause any other unwelcome behavior in the system, then we have that time, that foresight, to take action, to take preventative measures. Moving forward into the forecast period, the further we get away from now, the less confidence we will likely have in our forecasts, but nevertheless we are given an indication of the likely flows and likely depths in the system, and at least we are given some advance notice there might be an issue in the future, and then future simulations will then tighten up that forecast and allow us to be more assured of our actions we're going to take. So in terms of the modes of operation within the system, flood forecasting systems are usually used to prevent flooding or at the very least reduce the impact of flooding. And if we can reduce flooding, we will by the same token reduce or prevent our pollution events, because the two tend to run in parallel. And that of course means that as a utility company you are much better positioned to protect the environment and of course most importantly of all protect the lives of the citizens that the utility is responsible for. Now, as an example of the typical applications that InfoWorks ICMLive is used for, I've got 3 examples here from the United Kingdom. The first is with Scottish Canals up in Glasgow. Up in Scotland, there are a number of canal systems, and the one that runs through Glasgow has obviously been there since the Victorian times, and the land on either side of the canal is very prone indeed to surface flooding. The stormwater system that exists there is somewhat under capacity, and as a result of the sensitive nature of the urban landscape next to the canals, it's not possible to redevelop the brownfield site for future housing at the moment. So InfoWorks ICMLive has been deployed in combination with a SCADA system that's constantly monitoring the canal levels, and in the event of forecasted rainfall in the future, a series of remote sensors are activated to change the levels of some control gates on the canal in order to drop the level of the canal by up to 10 centimeters. The effect of this is to make some 55,000 meters cubed of storage available for runoff, for stormwater runoff that would otherwise be directed to the catchment and would cause known flooding issues. So the canal system instead takes up that stormwater and then carries it out to the coastline as normal. The effect of this is to free up the land which previously would have flooded and make it available for building. And as a result of the live system that's now in operation, some 3,000 new homes, shops and businesses can be built. Now, of course, whenever you drop the canal levels, there is a risk to navigation. And so the final part of this smart canal system is to ensure that if the canal is going to be dropped, the forecasted rainfall will be enough to then refill the canal so that all times the system remains navigable for leisure activities, which is an important part of the overall income to the area involved in Glasgow. The second example is very different to the canal system. It's with Anglian Water, and they have a number of networks which discharge to coastal waters. Unfortunately, if there is a combination of a high tide with peak rainfall, the operations of the systems are known to result in flooding in the more inland areas where the urban areas are. So ICMLive has been deployed in Anglian Water in order to give that future foresight of when there might be a combination of both high tide, just from the regular tidal cycles, but also a peak in flows in the system as a result of a rainfall storm passing over the catchment coincident with the high tide. Now, when the system was first put in, it was in fact producing false alarms, which is the worst case scenario for a forecasting system. The general public are usually unforgiving of false alarms on systems like this. So Anglian Water had to go back and review the information that they were using. And what it showed was that the forecast rainfall that was being used was actually too coarse for the system. And once the input data was revised and a more precise data was used, together with some tweaks to the actual network model as well, we got a very, very good match indeed between peak rainfall and peak runoff and the tidal cycle in the local vicinity. And in fact, the system has now been so successful that this year, in May 2019, the whole system won an Innovation in Water award from the WAI. And that is a very prestigious award indeed. So much so that within Anglian Water, the ICMLive system is now being rolled out across operations, across planning, and even with the asset management teams in order to give all areas of Anglian Water's business much more foresight into their operational networks and any flooding and pollution problems that might well exist. Finally, I'd like to talk to you about the system that's been developed in London. A company called Tideway are working in combination with Thames Water to build a brand new stormwater relief tunnel underneath the path of the River Thames as it flows through London. At the moment, when the London sewer network fills due to rainfall, there are very large CSO chambers which take up the excess capacity. These chambers are some 4 to 5 meters in height. Once they fill to capacity, excess flow is discharged into the River Thames. Clearly an undesirable situation. The construction of the Tideway tunnel will pick up those flows and prevent those CSO discharges. But during the construction of the tunnel, there is a large workforce of many thousand people operating underground. And in the event of forecast rainfall, these large CSO chambers will actually fill to capacity, so fill by 4 to 5 meters in height in less than 15 minutes. That is not enough time for construction staff to be exited from the underground system. So ICMLive is used to forecast storm events and to forecast the likely water levels within areas of the construction system such that staff have time to be evacuated from the network and therefore there is no danger to life. The system is monitoring some 40 connection points into the tunnel network, and the system, as you can see here in this snapshot, is a very complex network, but nevertheless the hydraulic model that's forecasting the system with ICMLive does run in under 25 minutes. Once the depth loggers report that there is an issue, the outputs will show on the operations screens at Thames Water HQ. And you can see here in this screenshot, the forecasted rainfall is coming in from top left, shown in the green and the blue squares that are traveling in a southeasterly direction across London, which is the relevant direction that storms travel. And you can see the predicted response of the stormwater network shown in areas of the network which are going blue and going purple. And these are the alerts that are sent into the control room, and then as a result of that, staff are evacuated, construction staff are evacuated from the underground system in advance of the rainfall system arriving and the tunnel filling with water. So that's 3 examples that we have of ICMLive being used here in the United Kingdom, very different applications, and it shows the diversity that the software can be put to. But of course there are other applications in progress across the globe. We have operations in the United States, across mainland Europe, and a significant number of installations in Asia as well. And with some of these systems, the outputs from the ICMLive system is not only informing the control room and the operations center of the utilities concerned, but in some cases, some of the outputs are actually shown on public-facing websites so that members of the general public can actually see for themselves the forecasted systems in operation. Now, in terms of system setup, the system obviously requires a degree of construction, and we will provide some 2 weeks of implementation support for the software. So training on the actual ICMLive would typically take in the order of 2 to 3 days. Then there would be some model preparation and connectivity of the live data feeds. And then probably there would be a small break while everybody gets familiar with the system as set up. And then in a second session, we would look to help the utility company or the consultancy to set up the initial runs, develop the alerts that the system is producing, and if applicable, develop the exports which will be going into third-party systems. As I said, it's usually a 2-week period based on previous experience, but we would look to split that into 2 sessions. I think we can finish with a final word, which really came from the infrastructure modeler at Anglian Water, who very eloquently described the advances that ICMLive has allowed Anglian Water to make. And they stated, very openly that the sort of proactive, intelligent network modelling, and therefore the predictive analysis that they have has really allowed Anglian Water to remain something of a frontier performer, both in eyes of the UK regulator, but also in the wider industry as well. So I'd like to thank you for your time, and I hope that you enjoyed this quick look at the InfoWorks ICMLive system from Innovyze.